Teardown time. This is the Cree Connected LED light bulb. What's special about this one is it has a Zigbee interface into it, which allows it to be wirelessly and remotely controlled through a gateway. I'm going to tear the bulb apart and see how it's assembled and see the functionality that they had to insert into this bulb to create a wireless interface. If you're familiar with Cree's products, it actually looks like a Cree 4-flow, at least externally. So it says that it's works with a Wink hub. I'm not sure what that is. One problem I faced when I was buying the bulb was it wasn't very clear actually how you control it. Cree doesn't seem to actually sell any controllers for the bulb, and there seems to be a real collection of controllers at Home Depot, but no idea whether or not they work with this bulb. Yeah, it does look like a 4-flow, except it must have some circuitry sitting in there somehow. Let's knock off the shell and see what we can find. So I just saw the shell off here, and the base seems to have now the bulb, and it becomes quite apparent that they've actually added a circuit board to their 4-flow assembly, sitting right here, and I presume that's the Zigbee controller. So let's yank that out and see what we can see. Okay, yeah. It's a classic assembly. Cree actually is quite clever with their little connector here to create this sort of XY plane. 2 circuit boards. Cree really likes this sort of limited hand soldering approach to their designs. They've been very consistent in that. It doesn't look like very many LEDs on this bulb, just 4 on each side, so 8 LEDs. What was it, 60 watt equivalency? Yep, 60 watt equivalency according to the box. So let's take a look at the board here. Okay, so I took the 2 integrated circuits off of the little tiny control board. That was a little half moon board here. There's actually 3 integrated circuits inside of it. There's a larger die here, which is a microprocessor. There's an RF controller, essentially the Zigbee controller on top of that die. And then there's this little 4 megabit flash EEPROM. Let's just zoom in. I used my camera and my microscope to capture a series of photographs. Let me just step through and pop those up and see what we can see. So the first circuit is an Atmel part. Let me just pop up the photograph of the die just before I de-encapsulated it. Of course, I had a part number. Points me to this data sheet, the Atmel SAM-R21E ARM-based smart wireless controller. It's actually an incredibly complex part for such a simple function to manage the bulb. I presume this is why Zigbee probably isn't going to be a really super deeply popular protocol. It seems to require a tremendous amount of computing resources. This is a ARM Cortex-M0 processor with an RF die on top. Let's see, there's the photograph of the actual Atmel processor. As mentioned, Cortex M0, that's actually a fairly decent bit of computing power. The purple side of the die is undoubtedly the RAM and ROM, and on the left-hand side, sort of the randoming-looking logic is the actual microprocessor, plus the peripherals around it. If I go to the next picture, a little more interesting actually. This is a RF transceiver. Interestingly enough, the Atmel datasheet doesn't say it's Zigbee only. It says it's simply a 2.4 gigahertz ISM, which is the band where all the Wi-Fi and Bluetooth and Zigbees can live. So I'm not sure if this chip's actually capable of more than that. Nice thing about RF chips is they're actually very attractive. The hexagons there on the center left are bifilar transformers or inductors. The black box below some of those inductors, probably a capacitor. Essentially that part of the die is the RF section of it. And then on the right-hand die is sort of the so-called random logic, which is the steering logic to control the actual RF module. Wouldn't be too surprised to see something like an 8051 type microcontroller running the whole show here for this bit of silicon. This little bit of silicon is actually put on top of the ARM processor, then all packaged together. Tremendous amount of advancements in dies stacking the last decade as cell phones demanded more. The last little die is a SPI boot PROM, a Desto. Interesting, you see that M in a circle, that's a mask copyright. You always think of copyrights as a C, but Silicon Dies actually got their own legal protection in the United States, coming on 30 years ago, I guess. Interesting thing about SPI PROMs is that they have the pads all over the place, but the arrays in the middle. So the bottom there is the actual steering logic. There's some charge controllers. The programming of a flash requires fairly high voltages, so there's actually a lot of voltage booster circuits in the bottom part of that die. And then the actual array is the very pink looking die. And they actually then just simply run wires all over the die on the top there. I guess it doesn't affect the structures below to create the connectivity. So there you go, a little tiny circuit board, a little tiny bulb, not bought for much money, and 3 actually really fairly complete bits of semiconductors there. So the main circuit board is also a little more complicated than the Cree 4-flow because there has to be the ability to actually turn the LEDs on and off. But the topology is standard in the sense that there's a fuse here, then it goes into a full wave rectifier to create a high DC voltage. Obviously a very large switching inductor for some control circuitry. On the other side, I presume there is some sort of switching regulator which controls the LEDs. There's that little tiny switch I so like from Cree. It allows them to connect to the actual side of the AC input. A lot of manufacturing engineering excellence in Cree bulbs. The capacitor is a Nichicon Chemicon, which is a very well-regarded vendor. Otherwise, it's sort of, it looks like a classic bit of Cree engineering. Well, there you go. That was a lot of fun, actually, and always taking a look at these integrated circuits. Tremendous complexity. I think Zigbee must require some heavy compute power. I was really surprised how much circuitry was sitting on that little controller. If you're wondering why there's no video here of me turning it on and off with my iPhone or sort of remote control, I didn't buy a controller because they're coming into about $100 actually, and the reviews on them are pretty spotty. So I'm not sure if Zigbee is ready for prime time, and certainly wasn't willing to spend another $100 just to prove that indeed the bulb can be turned on and off. Well, there we go. That's how Cree approached their wireless remote controlled bulb.